Let x and y be two jointly continuous random variables with the PDF given here. Calculate the covariance of x and y and the correlation of x and y. First, let's figure out this region here. In this x and y plane, since x plus y is less than or equal to 1, we can write this as y is less than or equal to 1 minus x. In this xy plane, this is the line y is equal to 1 minus x. Since y is less than or equal to 1 minus x, so the region must be below this line. And since x is greater than 0, y is greater than 0, so the region must be in the first quadrant. So the region must be below this line and in the first quadrant of this xy plane. So the region specified here is the triangular here, right? So which is the shaded area here. Now, to compute the marginal density of x, let's first assume that x is between 0 and 1. As you can see, the density function is 2 in this region. Outside of the region is 0. So in this range, x can take a value from 0 to 1. Let's assume that x is between 0 and 1. Let's compute the marginal density for x. So the marginal density of x is equal to the integral from negative infinity to positive infinity, the joint density of x and y, d of y. Since we're computing the density function for x, we need to integral out the y. And this is equal to, and based on this plot here, we can see that for fixed x, the y ranges from 0 to 1 minus x. Outside of this range, the joint density is going to be 0. So this is equal to from 0 to 1 minus x to d of y. And this is equal to 2 times 1 minus x. This is when x is between 0 and 1. If x is outside of this range, and this joint density function is all 0, so the marginal density of x is also 0 outside of this range. So now we have the density function of x is equal to 2 times 1 minus x when x is between 0 and 1. And it's 0 otherwise. Now let's compute the expected value of x. So expected value of x is equal to the integral x times the density function of x, d of x. Now since x is equal to 2 times 1 minus x when x is between 0 and 1, is 0 otherwise. So the integral is just, we can compute the integral from 0 to 1, right? Because outside of this 0 and 1, this whole thing is 0. So this is equal to, from 0 to 1, x times 2 times 1 minus x, right? So fx is 2 times 1 minus x, d of x, and this is equal to 1 over 3. Now let's compute the expected value of x squared, and this is equal to integral from 0 to 1 x squared f x d of x, and this is equal to from 0 to 1 x squared times 2 1 minus x d of x, and this is equal to 1 over 6. Now the variance of x is equal to the expected value of x squared subtract e of x squared, and this is equal to 1 over 18. Now similarly, we can compute the expected value of y, and which is also equal to 1 over 3. The variance of y is equal to 1 over 18. Now to compute the covariance of x, y, let's first compute the expected value of x times y, and this is equal to the integral x y times joint density of xy dy dx. The order here doesn't matter. Now, since the joint density is equal to 2 in this region, and it's 0 outside of this region, so we can just integral in this region. Now, in this region, x ranges from 0 to 1, so in the outside integral, x is ranging from 0 to 1. For the inside integral, for fixed x, y ranges from 0 to y minus x. So this inside integral is going to range from 0 to 1 minus x. And this is equal to integral from 0 to 1, integral from 0 to 1 minus x, xy times 2, because in this range, the density function is 2, dy dx. And this is equal to, from 0 to 1, x times 1 minus x squared. Here we just integral out this y, right? So d of x, and this is equal to 1 over 12. Now we're ready to compute the covariance of x and y. So the covariance of x and y is equal to the expected value of x times y subtract expected value of x times expected value of y. Now we already computed the expected value of xy is equal to 1 over 12, and e of x is equal to 1/3. E of y is also equal to 1/3. So this is equal to negative 1 over 36. Now the correlation of x and y is equal to the covariance of x and y divided by the square root of variance of x times the square root of variance of y. And this is equal to negative 1/2. Thank you for watching.